Okay, today's note session is about power. And we've been talking a lot about work, and we haven't really been talking about the time it takes for us to get the work done and what that means. So let's take a look at this idea of work and how much time it takes us to do the work and what that has to do with power. So we know that energy can be transformed from one form into another, and that can be done either quickly or slowly. The rate at which energy is changed is called power. Power can also be defined as the work done in a given amount of time. Okay, so let's try this. John lifted 10 50 Newton boxes to a shelf that was 2 meters high in 5 minutes, and Jack lifted also 10 50 Newton boxes to the same shelf in 10 minutes. Who did more work? When we look at the work equation, you'll see that time really isn't involved anywhere in here. So John, who takes his 10 50 Newton boxes or 500 Newtons and moves at a distance of 2 meters, does 1,000 joules of work. And Jack, who takes his 10 Newton boxes for a total of 500 Newton boxes up to the shelf of 2 meters, he also does 1,000 joules of work. So John and Jack are both doing 1,000 joules of work. They're doing the same amount of work. The fact that John does it in 5 minutes and he does it in 10 minutes or whatever the time was, really doesn't have any bearing on how much work is being done. Okay, so how about the time? Power is a quantity that also considers time. Power is defined as the rate at which work is done. So how fast I'm getting my work is done is defining my power. Power, if we can calculate it, is the amount of work divided by the time. So power equals work divided by time. Because work is in joules and time is in seconds, we get a unit of a joule per second, or a watt. And if I have 1,000 watts, that equals 1 kilowatt. So when we're taking a look at the difference between the work done by John and the work done by Jack, they did the same amount of work, but let's see who had more power. John did his 1,000 joules of work in 300 seconds for a total of 3.33 watts. 3 watts using significant figures. Jack did his 1,000 joules of work in 600 seconds. So he did about, if we're going to use significant figures, 2 watts of work. But I kept it out of the significant figures so that you could see double the time, half the power, right? So even though John and Jack did the same amount of work, John did his work faster, so he has more power. So when you tell me that, gee, Miss Patier, it took me 4 hours to study for that test, I don't understand, my answer to that is that how much studying you do, the amount of studying you do in a certain amount of time has more to do with your power. Since knowledge is power, maybe you didn't have as much knowledge as you should have on the topic, and so you didn't have much power, and it took you longer to study for the test than you should have. Okay? In class, we're going to take a look at this concept of power by doing some power equations. And we're also going to do an activity in which you're calculating how much horsepower you have doing an activity that we do every day.